Good morning, dear students. We are dealing with the chapter liquid state, and in the previous class, we have discussed some of the general properties of liquids and how they differ from solid state and gaseous state. And also, we have discussed free volume, the term free volume, what is free volume and what is the value of free volume, etc. So in today's class, our topic of discussion is surface tension. It is an important property for a liquid. It can be represented as gamma by the letter gamma. We can move to surface tension in a detailed manner. Okay. Look at the figure. In the figure, a liquid is taken in the beaker and there are two molecules. Two molecules are represented in the figure. Two liquid molecules. One is P and the other one is R. What is the difference in position between these two molecules? The molecule P is in the bulk of the or body of the liquid and the molecule R is at the surface of the liquid. And the arrow marks, arrows indicating the forces of attraction from other molecules in the liquid. Okay, then you can see for the molecule P, there is an equal attraction from other molecule, or the molecule P is attracted equally by other molecule. So the net effect or the net force on the molecule P will be 0. All force will be cancelled each other. And what about the case of molecule R? You can see that for the molecule R, there is a downward pull because the molecule R is at the surface of the liquid. So there is no molecule above that molecule. It is the surface of the molecule. So at the above the surface of the molecule there will be air. So there is no molecules of the liquid. So the force of attraction experiencing on the molecule R is from the molecule in the down or lower side of the liquid and from the surface. So there is no molecule at the upper side of this molecule. So the molecule R will experience a downward pull. A molecule in the body of the liquid is attracted equally in all directions by other molecules and cancel the effect of one another. For a molecule at the surface, the downward attracted forces are greater than the upward forces. These unbalanced attractive forces acting downward tend to draw the surface molecules into the body of the liquid. Hence, the surface area will be minimum. So, for a molecule in the bulk of the liquid, there will be an equal attractive force from other molecule surrounding it. So, the net effect will be cancelled or net effect will be 0. But for a molecule at the surface of the liquid, there is a greater downward force because there is no molecules at the upper side of that surface molecule. So there is a downward pull or the attraction downward will be greater than the upward forces. So these unbalanced attractive forces acting downward tend to draw the surface molecules into the body of the liquid. These unbalanced downward forces will draw the surface molecule downward. So the surface area will be minimum. molecules will try to occupy a minimum surface area. The molecule in the bulk of the liquid possesses less energy compared to the molecule at the surface. The extra energy of a surface molecule is the reason for its tendency to move into the bulk of the liquid. As a result, the number of molecules at the surface will be less. The surface molecule tend to move closer to acquire a normal distance. This is the reason for the spherical shape of liquid drops. So, we have discussed there is a downward force experience on the surface molecule. So, what we can say about the energy of the surface molecule, or what will be the energy of a molecule in the bulk of the liquid. For a molecule in the bulk of the liquid, there is an equal attraction from other molecule. So, this molecule will experience a less energy, or the molecule in the bulk will experience a less energy compared to the molecule at the surface. Because at the surface, there is an unbalanced downward force. So, there will be more energy for the surface molecule than the molecule in the bulk. This extra energy of the surface molecule is the reason for its tendency to move into the bulk of the liquid. Because a molecule or any system with high energy tend to lower the energy. So, for a molecule at the surface, the energy is high compared to the molecule in the bulk. So, the surface molecule tends to move to the bulk of the liquid to reduce its energy. Okay. As a result, the number of molecules at the surface will be less. So that there will be less molecules at the surface compared to the bulk. So, at the surface of a liquid, there will be lesser molecules. So, the distance between these surface molecule will be very high. And the surface molecule adjust the distance between them. So, they move closer to acquire a normal distance. As the number of molecules at the surface is less compared to bulk of the liquid, there will be a very high distance between the surface molecule. So, these surface molecules tend to move closer to reduce this distance and to acquire a normal distance between them. So, this is the reason for the spherical shape of liquid drops. We know the liquid drops are spherical in shape. This is the reason why a liquid drop is spherical in shape. Due to the tendency to contract, the surface of a liquid behaves as if it were in a state of tension. Due to the unbalanced downward force experiencing on the surface molecule, it behaves as the surface is in a state of tension. The force that tends to contract the surface of a liquid is known as surface tension. So, this tension of the surface molecule is the force that contract the surface. Due to the unbalanced downward force, there will be a contraction at the surface. I have said the surface area will be minimum. So, there will be a contraction at the surface. The force that tends to contract this surface is called surface tension. A surface tension can be defined as the force acting per unit length of the surface. The definition of surface tension is the force acting per unit length of the surface. It is called surface tension. It may be in SI unit, the force, unit of force is Newton. Newton per meter inverse. Newton per meter or Newton meter inverse. So this is surface tension. Okay, the molecule at the surface will experience an unbalanced downward force. This unbalanced downward force tends the surface to acquire a minimum surface area. So the surface will contract. Due to this, the surface of the liquid experience a state of tension. This state of tension is called surface tension, or surface tension can be defined as the force acting per unit length of the surface, and the unit of surface tension is Newton meter inverse or Newton per meter. It can be represented by the letter gamma.